we go. So scatter plots. Sorry, I lost my notes here. Here we go. So points that represent the data are drawn in the coordinate plane, right? That's the planes we've been using the whole time. And then the graph is examined to see if there's a trend or a correlation. So basically, that is like we're looking to see, like, is there something, a story that's being told by this graph? Specifically, we're looking at these points if they seem to cluster around a straight line or if they're completely spread out over the graph. So we're looking to see if they're spread out or if there's a straight line. And I'm just going to scroll down in just a second here to show you something. If you're looking at this one here, this looks like it's centered around a straight line, right? So that's what I'm talking about. I can see that there is a positive upward trend. There's a correlation between something here. Maybe, for example, maybe on the left is the, maybe it's like test scores, for example. Maybe on the bottom is how many hours, studied or something like that. Well, we can see there's probably a correlation right there, right? The more you study, oh, it looks like the higher grade you got. If you don't study at all, probably lower grade, right? So that could be an example of that. So that has a correlation. There is a trend there. We see that, there's a connection.
Will that be linear?
Yeah, it would still be a linear one. Yeah. We're primarily focused on scatter plots that we can make a linear relation out of. So if there appears to be a correlation between these points, we draw what's called a line of best fit. That red line I just drew down there, that's a line of best fit. So this line shows that general trend in that data. So something that's really important to note is it does not pass through all the points. It does not pass through all the points. Instead, we draw it so that the same number of points appear on above and below it. It's a line of best fit. It's trying to be the average between everything. Now, we also have some keywords here. I'm going to use a different color to kind of emphasize this. We have what's called a strong correlation. Oh, red might not have been the right color there. But that's the best color I have. So we have a strong correlation, whereas it's very obviously linked, or we might have a weak correlation when it's not so obvious. And again, if that's a little nuanced right now, it's like, well, what does he mean obvious and not obvious? We'll get into that. But so the words strong correlation and weak correlation are two things we need to extend this into. So when we have a line of best fit, we can get a bunch of information about that chart. And again, like, think about that chart I had down here, a bunch of dots like this. So that was that first chart that we had down there. We can learn a lot about it. We can learn whether this is a linear or a non-linear chart. We can learn about the strength. That's that strong or weak correlation. We can learn about the direction. Oh, that's a positive one. And we can learn if any outliers exist. Now, what the heck is an outlier? If I were to take the heights of, let's imagine you go into, trying to think of an example here. I don't know, you go to the grocery store and you take every person in that grocery store and you line them up from the shortest to the tallest person. If you have Michael Jordan in there, who's like 7'6", there's no one who's even close to him, right? Statistically speaking, that's really rare. So if this was a chart on, like, I don't know, height, Michael Jordan would be like way out here, right? That's an outlier. An outlier is a data point that lies significantly outside the general trend of the data. So let's figure out what all this stuff means. So we're going to come and put all four of these things here together: the shape, the strength, the direction, and the outliers. So we're going to do, make this red, 1, 2, 3, and 4. So that's what we're going to figure out with these bottom 4 graphs. So for these bottom 4 graphs, we're going to check to see if they're linear or nonlinear. That's number 1 here. That's the shape. We're going to check to see if it's direct or partial. That should be in our language, in our vocabulary by now. We want to see the direction of that correlation. That means we want to look at the strength of it, and we want to see if there's any outliers. So we're going to go through these charts one by one. So if I'm looking at this one here, this is just an example. I'm just going to delete that text. So my first question for you is, if you look at this, does this look like it's a straight line? If I was to draw one, yes, this is linear. Chart A is indeed linear. Now, the next question was, is it positive or is it negative?
Positive.
Positive. We know it's positive because as we go from left to right, it's going to go up, right? So I'm just going to draw a little bit of an example here. We'll learn how to properly draw this later, but that seems like it fits, right? Now, my next question for you is, does this seem like there's a really strong correlation, a strong trend happening?
Yes.
In this case, yes. This one is, sorry, positive. And then 3 was asking, is it a weak or a strong correlation? This is a strong correlation. I'll show you what a weak one looks like in a second. But this is indeed a strong correlation. And then finally, our final question here asked, is there any outliers? Is there any points in here that seem like they don't make sense? No, there's no outliers. Now, if I gave you a point way over here, that's an outlier, right? Doesn't match the data set I have. Now, in the same time, I got chart B here, right? So my question for you is, first one is, does this look like it could fit a straight line in it?
Yes.
Yes, this one would be a linear relation still. You can fit a straight line in here. Oh, and sorry, linear, and is it, for question 1, this would be a direct linear relation. Now for question B here, is this a direct or is this a partial?
Partial.
It would be partial, because remember, a partial one is where you have a straight line, but it does not go through 0, 0. This line looks like it's probably not going to go through there. So it's a partial linear relation. Now, is this a negative or a positive slope?
Negative.
Negative, right? It goes down. From you read it from left to right, it goes down. So negative. Now, we're looking at these 2 lines here. If this is a strong correlation, this one here is probably a weak one. Yeah. And so, like, I'm hoping that makes some more sense here. We're really looking at how those data points, how their distance to the line as a whole on an average. These ones really closely follow that. This one here on question B, that does, like, there is a correlation from the looks of it, but it's not as strong. Like there's just some instances where it doesn't quite fall into the trend it should. Now, my question for you is there any outliers in here?
Yes.
How many do you think there is?
2.
I would say at least 2. These two points I'm circling, yeah, those look like they're outliers. Now, there's some other ones that are a little further away, which you could probably make an argument for. I'm going to go ahead and say they're not outliers right now. But there would be 2. We're going to say there's at least 2 outliers, specifically at points 4, 5. That's that top right one. And at points, looks like, I don't know, a third and 1. I'm just going to put 0 and 1 to make it easy. So let's try out 2 more here. Question C. does this look like we can fit a line in here?
No.
No, not really. At best, like, maybe something like this, but again, there's another one going up there. It's a non-linear one. That doesn't seem like I could fit an actual line in there. So this would be non-linear. Oops, linear. Now, because it's non-linear, that's going to mean that there is no correlation. I have correlation if I can fit a line in there. Or if, it just makes logical sense. In this case, there's no correlation. There's not a strong one, it's just there's none. Oh, sorry. Number 2 is the slope, and there's no slope because we can't put a line in there. Number 3 is no correlation. Sorry, I messed up. So number 2 is no slope. Number 3 is no correlation. And then number 4 is there any outliers? Well, this is a null question. It doesn't exist. If we don't have a line, we don't have a correlation. We can't have outliers from it. So establishing that line is really important, right? If we know it's a linear relation, we can build the rest of this. If we don't have that, though, it's not that helpful. But now if I look at question 4, first off, is this a straight line? No, it's non-linear. But could I draw some lines in there?
Yeah.
Probably. This looks like it's a little bit of a curved line, but there's a very clear trend we see there, right? So it is a non-linear line, but we can still make a line out of it. So you can have non-linear lines that still have a correlation, that still have outliers. It all depends on how the data is plotted. So this one's clearly positive. Does it seem like there's a good correlation with this?
Yeah.
Yeah, there's a strong correlation here, right? Am I spelling this wrong? No. And then finally, is there any outliers here?
No.
No, not really. It seems like a really strong correlation. I don't see a point that's, way over here. So yeah, there's no outliers. So again, those are just some examples here to kind of visualize what some of these definitions mean. So just gonna screw. So I'll leave this up here for a second, but if you have these notes down, you can try out that next question. There's question 1 down there. And question 2. I'm just gonna give you guys just a minute there to try those 2 questions out. We'll quickly power through them if you're still not sure. But I'll give you, I'm gonna say like 3 minutes to try those 2 questions out. So question 1, question 2, you're gonna have to flip another page, sorry. Try out these 2 questions. Just gonna pause my recording. I'm just looking at question 1 here. So I just want to start looking at some similarities. Now, does anyone have any guesses as to what might be similar between these 2 graphs?
Both linear.
They are indeed both linear, yes.
And then both positive.
They are both positive. Is there anything else that might be similar between them? Some of the things you looked up above were like, are they direct or indirect or partial? These ones would be both partial linear relations. And this is kind of nitpicking a little bit, but if I were to draw this line, or what I think it should look like, we'll learn how to do that soon. It looks like they both come out at the same point. They both have a y-intercept of 1. So those are some examples there of some similarities. Now, what about for differences? What's different between these two charts?
One's strong and one's weak.
Yeah, so chart A shows a strong correlation. In chart B, oh, come on, shows weak correlation. So that's one of them.
And one has an outlier. In the other one.
Yeah, question A here does have an outlier. And graph B does not. This seems simple enough, right? Look at a graph and I don't know, see what the graph's telling you, right? So that's a kind of our primary focus here right now. I'll give you another minute or two here to draw your scatter plot on question 2, or at least do your best. We'll go through it together if you're not sure what to do. But I will give you a couple minutes here just to finish up question 2. So I'm just going to quickly do some scaling of this graph. I don't see any negatives here, so I can use the whole chart. I know this is my X, this is my Y. I know it's my standard 15 by 15 grid. My Y goes up to 5.5. I'm going to go up by 2s then. Sorry, not that. So I'm going to go up by 1/2 is a better way of saying that. And then my X goes up to 6. So that same scaling will work. So if you haven't started yet, it's done the exact same way we've done all of our normal graphs, right? Figure out your scaling. You already have your data generated, plot the points. So I'm going to quickly do that. I'm just going to plot them one by one. So when X is 6, Y is 5. When X is 5, 3. X is 2.5. It's 3.5. We got another couple seconds here. So at this point, we have our chart established. So if you haven't yet, give you a couple seconds here, just work on question 2B. So let's I'm gonna be going up and down a little bit here just because of like how their positions. You know what? No, I'm just gonna do this. I'm gonna zoom out a little bit. Okay. So question B, part one of it is asking us, is it linear or non-linear?
We'll say yes.
You'd say,
Linear, sorry.
yeah. So yes, it looks like it is a little bit of a linear correlation here, right? It looks like the further to the right we go, the higher up we go. The further to the left we are, the further down we are. So it looks like there is a linear correlation there. And then does this look like it would be direct or partial? Probably a direct. It looks like it's probably going to go through 0, 0 if we were to draw a line here. Now, for the direction of the correlation,
Pause.
it would indeed be positive. And then what's the strength of this correlation we're thinking of?
I said weak.
It looks like a pretty weak correlation. You're gonna notice I haven't drawn a line in here yet. Would it not be easier probably if we had a line? Yes, so that's what we're gonna learn to draw next. And then is there any outliers you think from this? Okay, we don't really have a line.
Yeah, I'd say
Which point do you think it would be?
4 and 5.5.
Probably this point, yeah. This if there is an outlier, and even then we're maybe like the graph looks like it's gonna kind of go like this. It's a maybe right now, but if there is one, it probably would be that one. Yeah. So looks like what is that at? 4.04 and 5.5. So yeah, probably 4 and 5 point. Yeah, 5.5. Oof. 5.5. Okay, so now we're going to actually learn how to draw a line here. And I'm just going to scroll up just really quickly to our definitions here. So again, what is a line of best fit? A line of best fit is when we see, if we see there's a correlation between the points, if we see there's a trend, we can draw that line. And that line is the goal of this is to have the same number of points appear above and below it. So if I'm looking at the one on example 2 here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have a total of 10 points. My general goal is I want to have 5 above my line and 5 below my line. Maybe I'll have like a 4 and a 6. Maybe I'll have a something like that too. But right, I want about half my points above and about half my points below. That's the general goal here, right? So a line of best fit can be drawn starting at the origin because this looks like a direct one. It does not need to go through any of the data points, but we want to try and get above and below. Now, this is what we call an approximation. We are doing an educated guess, and that's okay. Like I said before, all of our graphs are usually going to look a little bit different. So what I like doing is I like taking like a pencil, for example, and I just like, or a ruler even. You could take a ruler and you could lift it up so you only see the line, and you can count how many points are above and below. So if I did something like this with a ruler or a pencil, or I did even a fake, very lightly shaded line, well, I could say I have 1, 2, 3, I have 4 points above, I have 1 point on the line, and I have 1, 2, 3, 4, 5 below. This line probably would work. Again, I'm just trying to get a general mix here. So this line here probably would work. You might get a line that might go like, let's say it's like that. And that would be fine too. Again, imagine it's straight. I do not have the capacity to make a straight line on this software. But again, you're just doing your best guess. You're not going to get dock marks like, this is 1 millimeter too low of where I wanted. Okay. As long as you can see the general trend and you can draw a line that somewhat accurately depicts that, that is totally okay. So again, if I really wanted to write my steps out here, all I did was I counted the number of dots and I found a line with half above and below. If I really wanted to write down a step-by-step procedure, that's what it is, right? Oh, come on. That might be as small as I can get it. No, it's not. So I'm not done though. Remember, really important, always read the question. It wanted me to draw a best line of the scatter plot, but it also wanted me to write an equation. So that was what we had started looking at a little bit yesterday. It also wants me to now draw an equation of this line. So I can now take just a bunch of points and I now know that they're connected, they have a correlation, they have an equation for them, all this stuff. So I'm going to start drawing an equation here for this point. Now, the second I have an equation, I always have a God formula, which is y equals mx plus b. That is something you're going to have to memorize at some point in this course. This is not going to be on your formula sheet. Y equals mx plus b is just something we need. So this is my equation for a formula, right? But I only need 2 of these 4 things. Do you remember which of those 2 they are?
Slope.
The slope, which is m, and the y-intercept, which is b. So those are the only 2 things I actually need here. So I'm going to start by b just because I can literally tell it like look at the graph and see. So my y-intercept, which is what B is, at what point does my graph seem to cross the y-axis? And to visualize it, the y-axis is this blue line here. Well, doesn't it cross right here? So that would be 0. So in this case, my y-intercept would be 0 because it passes the y-axis, this blue line, when that number itself is 0. Now, the other thing I need is slope. I need to know what my slope, which is m, is. You don't need to write literally physically the word slope. I'm doing it because it's an example. You could just write m. M equals. Now, we know that it's equal to rise over run. Now, we do normally have an equation for it, which is, y2 minus y1 all divided by x2 minus x1. Now, here's where it gets really, really complicated. A lot of people are going to look at these points here, these black dots, and be like, oh, those are my points. So I can use this point, I can use this point. Well, no. That's a trend. It's a weakly correlated trend. When I talk about points, I mean points on my line, the line that I have drawn. And I want nice, easy points. I could give you, I'm just going to zoom in for a second. I know you're still right. I'm just going to zoom in. So I need 2 points, right? I could pick this point here, but that's not a nice clean number. What is that, like 4.4 and 2.6? Not going to work out that well, right? I want nice points. This one seems nice, right? X is 2, Y is 1. That's a nice, easy point. This one right here, X is 10, Y is 6. That's a nice, easy point. I want easy points to work with, right? And now I'm just doing the same thing I've always done. Is now I have 2 points. I'm using my formula to be able to find the slope of it. It's also direct linear relation, so like I could also just go up and down, but I like pushing this just because it's more helpful. So y2 minus y1 all divided by x2 minus x1. I'm typing it, but those 2's and 1's are supposed to be really small. So I'm just going to quickly label my points up here. I know my 1's is the first point I see as I go from left to right is 2 and 1 on my graph. And I know the second point I see, the 2, is x is 10 and y is 6. Now at this point, this is something we practiced a bunch. We should be able to do this. So I'm not going to fully explain it. I'm just going to do it. My y2 is my 6 minus 1. So 6 minus 1 all over my x2 minus x1, 10 minus 2. Which is going to give me 5 over 8. Now, if your graph, if your line was a little different, maybe your line was like this, you might get a different slope because maybe you're like, oh, I'm going to use this point instead because that seems like it's close. And that's fine. It is an approximation. You are doing your best guess. So your official slope might be a little different. Your y-intercept will probably be the same. But in this case, now I have my m, I have my b. All I now need to do is type that in, right? Y equals, instead of m, it's 5 over 8. X plus my b is 0. So I could just delete it, right? Y equals 5 over 8x. I'll give you a second just to finish writing that down. Okay, so like that's scatter plots, and I'm gonna be honest with you, like that's kind of it. Like that's the whole unit in general. Now, there's still some complications with this, but that's generally about as deep as it goes. You are going to get some time to work on some of these questions. Now, there's just something I really quickly want to mention. Let me go to my notes. What's this one? Oh yeah, question 3. Here we go. So I'm going to get you guys some opportunity here. Try out question 3, try out question 4. Now, question 4 specifically, you're going to want to really read this quite carefully. Now, the one thing I will say is question 4 is saying it's going to actually have you add points. It's giving you a line. It wants you to add points that kind of balance it out. One thing you can kind of do that is I'll give you a really big tip here. I'm just going to zoom in on question 4. This is on page 61. I'm just going to zoom in. If I want to add 8 points here that make the drawn line of best fit appropriate, that seem to make sense. The easiest way is I'm going to take the distance that this point's away from this line. That looks like it's, I don't know, 1.5. I'm going to go the same distance away and just draw a point. And that seems to work, right? Like that seems like it's kind of close. Same thing here. This one looks like it's 2 away. I'm going to go just 2 away. So that's something that you can do as kind of like a little bit of a cheat code for that. So I just quickly wanted to mention that one. And then I'm also going to have you guys try out example 3 here. This one has 2. You are going to draw 2 lines here. So I'm going to cut you guys loose here and give you guys some time to work on this. You're going to be able to work on your 2 assignments. Those are both due on the 30th. That's the Tuesday. There's no class Monday. Every Carleton Trail professor is away that day. There will be no class Monday. So I'll just write down these instructions here. I'll put it right here. So you have time to finish the booklet straight up. You're gonna notice if you go down to page. Nope. Page 72, there's a sample test there. This is not the actual test. Page 72 is just an example one. It's a good review because some of the stuff we haven't officially looked at in a week now. So I'm going to recommend that you finish the booklet, which includes, try and include that test. You have your Desmos assignment. That's that linear relations ones. You have I call them the exam style questions. And so what I think is going to happen is on the 30th afternoon, there will be a concept check. This is my fancy way of saying a test. It's not going to be, okay, guys, 12:30, here's a test. It's not going to be that. Instead, it's going to probably happen like around 2 o'clock or so. So you'll have some time to review because at that point, I don't like giving them fresh right after a weekend. So you'll have a little bit of time for that. But that's kind of the agenda here. So you have time to finish the booklet, finish your 2 assignments. Please submit them. If you asked me a question, if you wrote a comment in your assignment online, I would have responded to you. I think Alicia, I had replied to you there if you haven't seen yet. But so you have your 2 assignments due, you have your booklet, There will be a concept check on this stuff on the 30th. That's the Tuesday, and there's no school on Monday. And so if you guys have any questions, you want to help, please do ask. But yeah, with that, that's kind of everything.